Our planet is a vibrant, dynamic place. We often think of Earth as solid and unchanging, but the truth is far more exciting. Earth is constantly bombarded by energy from space. This energy comes from our sun, a star that powers all life on Earth. The sun is not always quiet and calm though. It throws out bursts of energy and particles, creating what we call space weather. This space weather can have surprising effects on our planet, from beautiful auroras to powerful geomagnetic storms. Let's embark on a journey to uncover the mysteries of Earth's wild ride through space. We'll explore the forces at play and their impact on our planet's present and future. Buckle up, space explorers, it's going to be an electrifying ride. Welcome to the Energy is All Channel Schumann Resonance. Imagine Earth surrounded by a giant bubble. This bubble is not made of soap, but of something invisible: electromagnetic waves. These waves bounce between the Earth's surface and the ionosphere, a layer in our atmosphere. This bouncing creates a kind of hum, a low-frequency resonance called the Schumann resonance. This resonance, like a heartbeat, is always present. It vibrates at a frequency of about 7.83 Hz, with other peaks at higher frequencies. Some scientists believe changes in the Schumann resonance could be linked to changes in our climate and even human behavior. While more research is needed, the Schumann resonance reminds us that our planet is a giant, interconnected system. The sun is constantly releasing a stream of charged particles called the solar wind. This wind travels through space and eventually reaches Earth. Luckily, our planet has a protective shield, its magnetic field. This field acts like a giant force field, deflecting most of the solar wind around Earth. However, the interaction between the solar wind and Earth's magnetic field is a dynamic dance. When the solar wind is particularly strong, it can compress Earth's magnetic field. This compression can cause disturbances called geomagnetic storms. These storms can disrupt satellites, communication systems, and even power grids on the ground. Solar flares, igniting climate change. Sometimes the sun releases sudden bursts of energy called solar flares. These flares release enormous amounts of radiation and charged particles into space. When these particles reach Earth, they can interact with our atmosphere. The energy from solar flares can heat the upper layers of our atmosphere. This heating can have a small but measurable impact on Earth's climate. Scientists are studying the link between solar activity and long-term climate patterns. While the sun plays a role in our climate, it's important to remember that human activities, particularly greenhouse gas emissions, are the dominant drivers of current climate change. Can solar winds make the Earth tremble? The idea that solar activity could trigger earthquakes is a fascinating one. Some scientists have proposed that changes in the Earth's magnetic field, caused by solar storms, might trigger earthquakes. The theory suggests that these magnetic changes could put stress on fault lines, potentially causing them to slip. However, the link between solar activity and earthquakes is still a topic of debate. While some studies have shown correlations, a definitive causal link has not been established. More research is needed to fully understand the complex relationship between space weather and seismic activity. Is Earth tipping over? Examining axial shifts. Earth spins on its axis, which is an imaginary line passing through the North and South poles. This axis is not perfectly straight, it's tilted at an angle. This tilt is what gives us our seasons. But is it possible for Earth's axis to shift? The answer is yes, but very slowly. Earth's axis wobbles slightly over thousands of years. This wobble is caused by the gravitational pull of the sun and moon. These axial shifts are natural and happen over very long periods. They are not related to solar activity or any immediate threat to our planet's stability. Forecasting the fury natural disasters in the future. Predicting natural disasters is a complex challenge. While we can't prevent earthquakes, volcanic eruptions, or hurricanes, we can work to understand them better. Scientists are constantly monitoring Earth's systems, looking for patterns and indicators that might help us prepare for future events. By studying past events and using sophisticated computer models, scientists can assess the likelihood of future disasters in certain regions. This information is crucial for developing early warning systems, improving infrastructure, and building more resilient communities. Thank you for tuning in. If you found this video interesting, please like and subscribe for more.